discovered yesterday is that if you had a pi over 12 family, and you want to find two things that add or subtract, there is always, always, always going to be a pi over 4. And it actually does not matter which pi over 4 you choose. They will all work and give you the exact same answer. So that's kind of nice. Be like, oh, like I chose 7 pi over 4 for 21 pi over 12. I think more often, people like to choose things that are close but less, because adding in your head is easier. So I think lots of people would probably choose 5 pi over 4 because they're like, oh, 15 pi over 12. What do I need to get 17 pi over 12? I would just have to add 2 pi over 12. And then once you reduce it, everything is on your pi plate. And the first value is your alpha, and the second value is your beta. And then you can go directly to your formula sheet and say, what is my cos alpha minus beta formula? It's cos plus sine sine. And since all of these are on our pi plate, we can plug them in. Now we do have to be careful with our cast rule. 7 pi over 4 is in quadrant 4. Pi over 3 is in quadrant 1. So in this case, when you do sine of 7 pi over 4, it has to be negative because sine is negative in quadrant 4. So it's still practicing our cast rule, our unit circle, our pi plate. And once again, we write our final answer as a fraction. And with sine and cosine, not with tangent, but with sine and cosine, in a pi over 12 questions, you will always get a root 6, you will always get a root 2, and it will be divisible by 4. Now on the exam, sometimes they have a part B to a question like this, where they say, can you find secant or cosecant of 17 pi over 12? Well, since in part A we found cos of 17 pi over 12, in part B here, or part II, secant of 17 pi over 12 will just be our answer flipped. There was one exam where they just asked a pi over 12 question with cosecant or secant, and if students had never seen that before, they just left that 4-mark question blank, which is a lot of marks to lose, right? So now, after that, and seeing how badly students did, and that, like, not wanting them to do badly, often if they're going to ask something like that, they're going to take a part A where they ask you to do the cos first, and then part B they'll ask the secant, just to see if you know. You just have to flip the answer. Here is another one from an old exam. It's a pi over 12 question. So this will be our last pi over 12 example. We have 4 cos of 11 pi over 12. So what's different in this one from the pi over 12 questions we've done before? There's a 4 in front. What does that 4 mean? It just means whatever answer you get for cos of 11 pi over 12, does it make sense you're going to multiply it by 4? Okay. Again, though, it's amazing what a little tiny change can do to you. Like there were students who knew how to do pi over 12 questions who left this blank because they're like, there's a 4. Okay, so this is an example of how sometimes on the exam, they add something small and different, and you have to be able to problem solve and say, okay, what does that small different thing do? What do I still know how to do, and can I work with that? So one thing that I might do in this question is just figure out cos of 11 pi over 12 first on its own. Again, I picked decided I'll just use pi over 4. Pi over 4 is 3 pi over 12. It is very easy to see what the other one has to be because what would add to 11 would have to be 8 pi over 12. So notation-wise, notice I have cos in front, I still have cos in front. I have 11 pi over 12, and now instead of 11 pi over 12, I've broken it up into two things that add up to 11 pi over 12. Next line, I reduced those to see which ones they were on the pi plate. Obviously, I knew pi over 4 already, but 8 pi over 12 reduces nicely to 2 pi over 3. And it's my cos alpha plus beta formula. So I can plug in alpha and I can plug in beta and get my answers from my pi plate. Once again, being careful if things are positive or negative. So pi over 4 is nice because it's always in quadrant 1, it's positive, but cos of 2 pi over 3 is negative because it's in quadrant 2. And once again, how do you multiply fractions? Multiply the tops, multiply the bottoms. That'll give us a common denominator of 4 for each one. And we get that cos of 11 pi over 12 is negative 2 minus negative root 2, minus negative root 6 all over 4. Question?
Why did you have plus in brackets, but then we go 12 in the brackets and it's minus?
So the question is, why do we have a plus here and then a minus there? So if you look at your cos alpha plus beta formula, and it's on your formula sheet, it's also up here on the wall. That formula, in fact, both cos formulas, the sign in the middle is different than the sign that's inside. But for the sign formulas, it's the same. So you have to be really careful that we just write down, you have the formula on your formula sheet. You have to be really careful that you write down the formula correctly. Okay.
So then, would that be in quadrants of 1 and 2? If you separated it?
So this alpha is in quadrant 1, yeah, and beta is in quadrant 2.
Okay.
And so when we plug them in, that's why when I did cos of 2 pi over 3, I had to write negative a half, because cos is negative in quadrant 2. So then that figured out cos of 11 pi over 12. What did the question ask us? The question asked us what was 4 cos of 11 pi over 12. So if I multiply both sides by 4, I multiply this side by 4 and this side by 4, well, then this 4 would cancel out. So I'd like you to circle question number 7 in your homework.